Okay, we have a system of equation of 3 variables. We could end up with one solution where we have one x, y, z that works, and we could have no solutions. The third one we could have is infinitely many. Okay. So far, we've only seen mainly solutions with only one solution. So how do we end up with no solutions or infinitely many? And the way you solve these, like you did before, nothing has changed. We start to try to cancel out variables that we think. So let's, in this case, cancel out. Let's do the x's, maybe. That looks like that will work. So if I change this to a positive, that'll be a positive x, positive 2y, positive 3z, and a positive 1. And then I'm going to use this equation to start canceling everyone else out. Okay. So for the first two equations, if I mix these two equations together, we end up with, so this is nothing new so far, we end up with y plus 2z equals to, that's going to be a plus a negative 2. And on the second set of equations, okay, second set, I'm going to mix those in my head. We're going to end up with, since the x's cancel out, we're going to end up with 2y plus 6z, is that right? Nope, not 2y. It's 3y plus 6z equals to 17. Does anyone have a question on what I did here? I changed the middle equation. You can change any equation you want. I just decided to choose the middle one, and I mixed it with my first equation. We ended up with the top. Then I mixed the second and third equation, and I ended up with the bottom. As you can tell, we went from 3 variables to only 2 variables. That's the process. Now here's our next step. We're going to get rid of our next variable, just like what we would normally do for these problems. So I'm going to multiply the top by negative 2. Is it okay? I'll multiply the top by negative 2. Oops, there's only 2 things. So once I do that, I'm going to show you my shorthand. This becomes a negative 2y. Whoops, let me write it a little nicer. This becomes a negative 2y, negative 4z, and a positive 4 at the end. Is everyone okay with that, or do you guys need me to write it out completely? If you want to write it out completely, this will become negative 2y minus 4z. Whoops, darn it. I don't know why I multiplied by 2. I should multiply by what number? Gosh. It should have been multiplied by negative 3, right? Yeah, right. Sorry. So negative 3 to the front and back. That becomes negative 3, negative 6, and positive 6. If you want to rewrite it, which you don't need to, but I want you guys to notice something on this step here. And this is what happens also when you guys, darn it, this is z equals to 17. You'll notice something kind of funky that happens to these variables. Normally when we cancel out one variable, only one variable cancels out. But if you notice here, the y's go away, as well as, take a look here, the x's, they both cancel out. They both cancel out. So what does that mean for us? It means this. We end up with 0 equals to 5. Now, I want you to think about this in math. Does 0 actually ever equal to 5? Does that even make sense? It doesn't, right? Whenever you have this weird convoluted statement, 0 equals to a number, 5 equals to 2. Does 5 equal to 2 in any type of reality? Does 7 equal to 9? This is totally not equal. These are not true statements. So what happens is, we don't end up with one solution. We don't end up with infinitely many solutions. We end up with no solution. So how would we describe the answer to this? No solution. So all the skills that we learned before, nothing has changed. We still try to get rid of a variable at a time. Get rid of a variable at a time, one at a time. And then we realize that, hey, we hit a point where it doesn't make any sense. That doesn't make any sense. In that case, we would write the answer no solution. When does it happen when it's infinitely many? Is what if instead of this step here, instead I see 5 equals to 5, or I see 0 equals to 0. Are these true statements? What did I get negative 12? I'm sorry. Negative 12 was from... Oh my gosh. You're right. Wait. Yeah, you're right. It should have been 6. I don't know why I wrote that. That should have been... Not 12, you're right. That should have been... This one here. That one should have been... That's wrong. That one should have been a... negative 3 times 2 is negative. So positive 6. Oh yeah, positive 6. I don't know why I wrote that. Positive 6. And this would have been 23. Still wrong. Sorry. Did the math wrong. But thank you for catching that, Aaliyah. So if I had done all my work and ended up with some true statement, 5 equals to 5, or 0 equals to 0, often is the case, we then instead say infinitely many. So there is no one answer that would solve this whole problem. It's actually in an infinitely many set of solutions.
Mr.